We are going to handle these questions, but we need to have background. So we are talking about hypothesis estimation, and testing. For today, our main focus is on how can you actually use Z-test and T-test. That is our main focus for today. But just for recap, we said that hypothesis, the definition of hypothesis simply means is just a stated belief, opinion, or it can be assumption. About the problem. The problem here, it depends on what you're researching. You are the researcher. What are you trying to figure out? And based on what you're trying to figure out, what is your belief about that? What is your opinion about that problem? What is your assumption about that problem? Okay, so that is all about hypothesis. Every time you hear the word hypothesis, just know that they are referring it to a stated belief. They are referring it to the opinion. They are referring it to an assumption about something. Then hypothesis testing. We said that this is a process. It's a process you're going to follow to confirm your stated opinion or stated belief about the problem. So basically here is the process of confirming whether the pre-existing opinion is true or false about a given population parameter. But basically, simply understand that with hypothesis testing, we are trying to confirm your stated belief. If you state that, okay, I assume that for students to pass, they must have read. That is your assumption. They must have read and understood. Or you assume that, okay, people who pass this subject are what? Are female students. That is your belief. But we cannot confirm that belief minus testing. So it means that once you state your hypothesis, we have to follow some steps. We have to follow some procedures to confirm whether you stated is true or false. And we said that we have types of hypothesis. Who can recall these types?
Null hypothesis.
Number one is null hypothesis. So we said null hypothesis is about what? What you state. You are the researcher. What you state. So this is formed. Basically, this is formed. This is formed by casting the doubt. By casting the doubt about the existing claim. So what you state, you as the researcher is your null hypothesis. And the process you're going to do, this process will follow to confirm whether what you stated is true or false, is that we are going to follow this step actually to confirm the null hypothesis. As we do testing, we are trying to confirm the null hypothesis, whether what you stated is true or false. And if we find that what you stated is false, then we will accept the alternative. That is type number 2. Hypothesis, alternative hypothesis. So this is simply the opposite. It's the one which is accepted. It's the one accepted when null hypothesis is rejected. So always know that we have only 2 types of hypothesis, null and alternative. And the null hypothesis is always defined as H0. Then alternative hypothesis is always defined as H1. So those are 2 types. But you see, we are talking about rejecting, accepting. We have along the process, you are the researcher. Actually, you may make errors. So we have what we call types of hypothesis, errors. That along the way you may accept null hypothesis, which is not true, and you may reject null hypothesis, which is not true. So we are saying that there are some types of errors you as the researcher you may make, and the first one is type 1. Type 1. First one is type 1 error. And what is all about type 1 error? This is an error. This is an error made when you reject the null hypothesis, and the claim was true. In simple terms, we are saying you rejected the null hypothesis. Remember, as we test, we are trying to actually either accept null hypothesis or we reject null hypothesis. So let's say you have tested your hypothesis and you have concluded that, okay, according to me, null hypothesis should not be accepted, or what this person stated is not true. You are rejecting null hypothesis. In a situation where you reject null hypothesis and it was true, that type of error is called type 1 error. Are we together, colleagues? Have you understood type 1 error? You are rejecting null hypothesis of which it was what? True. Then type number 2. Perfect. Type number 2 is type 1, rather type 2 error. Type 2 error. And what is all about type 2 error? This is an error made when you accept null hypothesis. When you accept null hypothesis and the claim was false. So that is type 2 error. You are accepting null hypothesis, yet that null hypothesis is false. You may say, okay, according to my testing, I can confirm that indeed null hypothesis should be accepted, or null hypothesis is true. But in actual sense, that null hypothesis was what? False. So the type of error in that regard would be type 2 error. So here you are rejecting null hypothesis. Here you are accepting null hypothesis. Rejecting it, yet it was true. Here you are accepting it, yet it was what? False. Okay? So also you should note that. But to understand this clearly, I may draw the diagram to help you. Assume this is your null hypothesis. Remember, we test null hypothesis, and null hypothesis is H naught. Null hypothesis is what? Is H naught. Null hypothesis is H naught. Assume this is our H naught. And we are saying here you have two options, either to accept or to reject. Here you have two options. You have two options, either to accept or to reject. So your null hypothesis can be true or it can be false, based on what you state. Here it can be true, or here it can be what? It can be false. What you state, you as the researcher. Your null hypothesis can either be true or false. Do you agree? Colleagues, do you agree? What you state, this one, can either be true or can be false. So you accept that. Then from here, we are saying if it is true, you may either accept or reject. You are the researcher. You are the researcher. You can decide here at this step to accept or to reject. Then also here you have two options. It may be false. Your null hypothesis may be false, but at the end of it all, you want to make a conclusion. That conclusion you are saying you can either accept this false hypothesis or you reject this false hypothesis. So here we are saying you have stated your null hypothesis. What you state can either be true or can be false. Can be true or false. But we are saying at the end of it all, you want to make a conclusion from what you stated. We want to make a conclusion by either accepting what you stated or rejecting what you stated. Okay? So, if the null hypothesis is true and you accept what you stated is true and you accept, here we say no error. Here we say what? No error. At this point, here you have made no error. Here there is no error. Because what you stated is true and you are accepting. So in such scenario, no error. But if what you stated is true, but for you, you conclude by rejecting, you see that actually you are making what? You are making error. Do you agree, colleagues? What you stated is true, but on conclusion, you are rejecting what was true. So in such scenario, we are saying that this is what? This is error. And what type of error is this? What you stated, the null hypothesis was true, but you are saying it is false. You are rejecting it. So analyze these two errors. Here, type 1 error. This is an error made when you reject the null hypothesis. Null hypothesis is here. You are rejecting null hypothesis, yet it was what? It was true. Are you seeing that, colleagues? So here, the null hypothesis was true, but you are rejecting. So in this situation, the error you have is called type what? In the chat, type 1. Yes. This is type 1 error. So you see how we are concluding? Then you go to the next. Here, the null hypothesis was false. What you stated was false. Okay? But you ended up by accepting. Do you have error here? Or there is no error?
Is an error.
Remember, don't rush, try to understand. If your null hypothesis was false, remember you are the researcher. We don't want to accept something that is wrong. Are we together? We don't want to accept that null hypothesis that was false. There is no way you are going to accept something that is false. Are we together? So if it is false, we expect you to reject. Are we together? If what you stated was wrong, we expect you to reject in the conclusion. If what you stated was correct, if what you stated was true, then we expect you to accept. That's why we are saying here there is no what? There is no error. Because what you stated was true. But here, if what you stated was false, then how can you accept the false hypothesis? So if you go ahead and accept the false null hypothesis, then we are saying here there is what? Colleagues, here we are saying there is what? Error. There is error. And which type of error is this? Which type of error is this? Colleagues, which type of error is this? In the chat, type 2. Yes, this is type 2. This is the error here. And the error you have is the type 2. The error you have here is type 2. Type 2. Type 2 error. So we are saying that if your null hypothesis was false, but you go ahead and accept that null hypothesis, we say that actually you have made an error, and that error is type 2 error. When you read this statement, you can see that this is error made when you accept. Here you are accepting null hypothesis, H note. You are accepting null hypothesis, of which that hypothesis was what? False. It was false here. But you are accepting it. But if the null hypothesis was false and you reject that null hypothesis, then we conclude by saying that here you have made no error. So here, no error, because you are rejecting what is false. You're rejecting what is false. I believe that's clear to all of you. If you need more clarification, let me know. But if there is no question, we can proceed. Have you understood this? Colleagues, have you understood this? I am always slow because I don't want to repeat these things. So try to understand them now. Okay, okay, in the chat, yes. All right, we can now proceed. We can proceed. So we know the meaning of hypothesis. We know the meaning of hypothesis testing. We know the types of hypothesis. Then now we know types of errors. Then next is to understand the difference between critical values and the critical region. Critical region. What is the difference between critical values and the critical region? With critical values, can start with critical values. Critical values can say these are values which separate the rejection region from acceptance region. Critical values are values which separate the rejection region from acceptance region. And these values, where do you get these values? We get critical value. We get critical values from the table. We get critical values from the what? From the table. And the table you can use here can be either Z distribution table, or it can be T distribution table. So every time we are reading the value from the table is to help us to create a line, separate acceptance region from rejection region. Every time we are getting values from the table, know that we want to create that line, separate our acceptance region from rejection region. Okay, then what is critical region? What is critical region? In short, colleagues, here with critical values, in short, this is like a threshold. This is like a threshold. Your critical value is like your threshold. So we talk about now the critical region. What is your critical region? What is your critical region? Critical region, colleagues. Critical region is like rejection region. Political region is like rejection region, and simply mean that political region is a set of contains set of values. Political region contains set of values of the test statistic. Test statistic, here we mean either it can be Z test or T test. If we hear the word test statistic, it can either be Z test or T test. Contains set of values of the test statistic for which the null hypothesis is rejected in a hypothesis test. The set of values, critical region, you can also say contains set of values in which the null hypothesis is rejected. Basically, every time you hear the word political region, we are meaning the region where we expect you to reject your null hypothesis. Every time you find that your values here, values of test statistic. Here, let me make it clear. Because we have value from the table, we also have the computed value. And if we are talking about values of the test statistic, here, actually, we are not meaning any other value apart from the computed value. Test statistic helps you to actually get the computed value of Z or of T. So you will be having the value from the table here, which sets your threshold. Then that value from the table, you will be asking yourself, does the computed value fall within the acceptance region? If it falls in the rejection region, then you will reject your null hypothesis. That's the meaning of this critical region. Of course, it contains those values, the values of which you're going to reject your null hypothesis. But the diagram can make it clear. Diagram, isn't it?
Yes.
Yes, Abe.
So, assume this is your diagram. This line we are putting here is our threshold. This line we are putting here is our threshold to separate the critical region from the acceptance region, to separate our rejection region from acceptance region. So the value here you see here is like our critical value. This is our critical value. This is our critical value. Is my network clear?
Yes.
Okay. So this is your critical value. We said critical value is that value that separates rejection region from acceptance region. So here it is separating this side I may draw this one is so this side is critical region, this side is critical region. Then between this one and this one is acceptance region. Does it make sense?
Does.
This side rejection region, this side rejection region. Then in between, it is your acceptance region. And we are saying if the computed value fall within the acceptance region, if it falls, if your test statistic, if the value of test statistic falls within acceptance region here, then you accept what? Null hypothesis. But if it falls, if it falls outside, or if it does not fall within the acceptance region and it falls in rejection region, then we do what? We reject.
It falls here.
So you will hear me talk about this as we do the number, as we do some of the calculation numbers. Okay?
Yes.
So that's basically our introduction. But also we have level of significance. Level of significance. Then we also have confidence level. Now, with level of significance, it will always show, this shows basically in simple terms, this shows the percentage of error. The percentage of error you are likely make. Then this one shows, basically, this shows the percentage of accuracy. Percentage of accuracy. I am not using hard words here. Whether you studied in good schools or not, just understand. So I'm not complicating things. Just with level of significance, every time you see level of significance, they are giving you the percentage of what? Error.
Error.
Then every time you see they have given you the confidence level, that is the percentage of accuracy. Because we know that, colleagues, as you are going to test, you're going to do sampling. We all know that. You do sampling, isn't it? You sample. If it, we always have population. We always have population. Then also from population we pick what?
Samples.
From population here, from here we pick samples. Okay, And because of that, you are going to actually make some errors. You can actually pick the sample. You can pick the sample which is not all that convenient or that knowledgeable about what you are trying to research about. And also another thing is that by the time you state if you don't want to look at this from this angle, you can look at what you state from the start, what you state as your hypothesis, what you state as your null hypothesis from start. What you state from start, we said it can be false or it can be what? True. So the percentage of finding that what you stated is true is always high. Because we don't expect you to start from wrong thing. We always assume that what you state is actually correct. Eh? That's what we assume. But along the way, as you state, you can make error or you can be correct. So look at this level of significance as the percentage of error. Then look at confidence level as percentage of accuracy from those two angles, from the sampling or from what you state. Okay? But and you realize that because of these two things, you realize that you cannot be 100% accurate. So it means that we will always find what we call standard error. We'll always find out as we do our workings. We'll always try to bring in this error, standard error. Because we know that you cannot be 100% accurate, it means that we need to provide in our calculations, in our computations, as we look for the computed value, as we look for the value of the test statistic, we will always create that line for standard error. And colleagues, as we read the value from the tables, it means that you need to analyze the percentage given. Always know that level of significance, the percentage is always lower. Here, percentage is always lower. Because we cannot actually, we always assume that the higher percentage is what? Accurate. So it means that the level of significance, that percentage will always be lower. Then the confidence level the percentage will always be what? Here the percentage will always be high. So don't see me as we do calculations, you will realize that sometimes they give you the confidence level. Sometimes they give you the confidence what level? Let's say they give you, 90%. What comes into your mind, colleagues? Is this level of significance or confidence level? Remember, percentage is always 100. So if they give you 90%, they are giving you what?
Confidence level.
They are giving you the percentage of accuracy, that is confidence level. And when we are reading the value from the table, when we are reading the value from the table, we are going to actually be focusing on the level of significance. as we read the value from the table, we are going to be focusing on the level of significance. So it means that every time you're given confidence level, you look for the level of significance. If you are given 90%, then what is level of significance? Here, level of significance will be what?
10.
10. So that going forward, I will be actually focusing on 10 because I want to read the value from the table, this value. I want to get the threshold. I will be having the computed value. And when you're getting this computed value, we are saying that we will create the standard error. You will create in the formula as you get the computed value, you will also include in your formula, you will include the standard error. So it means that by the time you're including standard error, then I should not focus on accuracy. I should also focus on the percentage of error as I read the value from the table. So don't confuse these two things. Don't confuse these two things. Okay. And percentage of error will always have the formula as we are going to see. But to simplify life, because that's where we are going, is that with standard error, we are going to find ourselves focusing on either mean or proportion in our questions. In our questions, we will find that you are either dealing with a question related to mean. You'll find that you are dealing with a question either related to mean or related to what? Proportion. If the question is related to mean, then standard error will be equal to standard deviation, then divided by root n. Where is root? Who is seeing the root sign? So we don't have a symbol here for root. So that will be your formula. Standard deviation divided by root n. That is if you're given, if you're dealing with mean. Only one mean here is only one mean. Only one mean. Because you will find that sometimes you're dealing with two means in the question. Then, if the question is related to, if the question is related to proportion, then standard error will be equal to root 2. It will be equal to root 2. It will be equal to root 2 PQ, then divided by N. And when you check in your handouts, actually all those things are there when you check in that document that I shared with you. You'll actually realize that all those things are there. You'll all find.
Excuse me,
Yes, please go ahead.
does the root only apply to PQ or to everything?
When it comes to proportion, it applies to everything. You see it here. Are you seeing it?
Yes.
Yes. So I provided everything. It means that with proportion, you will be given P. Then if you have P, you can get actually. Or if you have Q, you can get P. But all things are in this handout. You'll find that also you're dealing with two means. You're dealing with two means, and we will see. We will see how to handle. I don't want to follow me. I don't follow these things. I don't follow. I just the fact that this is revision. I don't follow handout the way it is. Now, if you are dealing with two means or two proportions, the standard error will change, as we are going to see moving forward. We are going to see moving forward. Then you need to differentiate what is the sign is. If you're talking about sample, if you're talking about sample mean, what is the sign? If you're talking about population mean, what is the sign? What is the sign you should use? If you're talking about standard deviation for sample, which sign should you use? If you are talking about standard deviation for population, which sign should you use? And the sign that you should use is actually in your what? In your guide. If it is mean and you are talking about sample, are you seeing what we use? X bar. But if it is population mean, we use what we call mu. If it is a standard deviation for sample, you'll find that we are using S. Then for population, you'll find that we are using sigma. When it comes to this signs, that's where you hit the subject, the topic. Sigma and what? New. But the pronunciation doesn't matter. What matters is knowing the what? Knowing the sign. If it comes to mean, we use this X bar. When it comes to population, we use mean. Okay? And with samples, the number of samples now. If it comes to some number of items, if it comes to sample, we use N. Then if it comes to population, we use what? Capital N. So don't forget that. Don't forget that. And I'm done with this. Done with this. Now with this background, we are going to start handling numbers. But as we handle numbers, we also have confidence interval. We have confidence interval. Confidence interval, every time you see the word confidence interval, they are calling you to get what? Range. Whereby you need the lower limit. Also, you need lower limit and the upper limit. So if they ask you to get confidence level, rather confidence interval. Confidence interval is different from confidence level. Confidence level just gives you the percentage of accuracy, but confidence interval, now they need you to get the range from the lower limit to upper limit. And there is a formula that we will be using. As you get your range, you are either using t-test, or z-test. When do you use t-test, and when do you use z-test? Do you recall, colleagues? When do we use t-test and when do you use the z-test? Who can recall? We use
t-test.
We use t-test.
When the sample is below 30.
When sample size is below 30. That is N, because we said the sign for the sample size is N, but for the population size is what? Capital N. So here we are saying if it is less than 30, we use t-test. Then we use z-test when sample size is 30 or above. N is greater or equal to 30. So I will be asking you now, are we going to use t-test or z-test? Okay. So I think it will be good to go. And I believe this is not the first time you are studying these things. I believe it is not the first time you are studying these things. Just that the first time you studied these things, you had bias. You had bias on the area. And also sometimes you find that you guys, you have bias on the person who is teaching you. So every time you have bias on the person who is teaching you, trust me, you cannot understand things. And if you have bias on a topic, also trust me, it's like hating a person or hating something. Totally, you will not like the area. So always try to actually like the person who is teaching you, appreciate what is delivering or what he or she is delivering. Also appreciate the topic. If others can understand the topic, why not you? Why not you? Why not you? Why not you? Just always believe that you can understand the topic. Don't be among, you know, as I said at start, people recruit other people to hate the topic. Do you know that, colleagues? Someone will start saying, hey, this topic is hard. Why are you telling the person that the topic is hard? Keep it to yourself. It may be hard to you and another person find it easier. That's why in an exam, we have options. Don't recruit others to hate the topic you are hating. The way people, these days, people recruit other people to hate another person. Find the person just is hating. You don't know the person, but because the other person recruited you, you are also hating the person. What is no, no. If the other person doesn't like this one, your friend can like him or her. So don't be such a kind of people. If the topic is hard, let it be hard to you. Don't recruit others to hate also that topic. And I always believe there is no topic that is hard, just that you have bias on the topic. You are not giving it maximum attention. Maybe because of the time, or maybe because also how it is being delivered. You immediately have bias. But me, I always believe there is no topic that is hard. It's all about appreciating the concepts. It's all about appreciating the concepts, and you put in more efforts, practice more numbers, and along the way, you will start appreciating and say, this topic, oh, it was even easier compared to what I thought. You will even start actually. It's like when you try to understand the person. At first, you may think the person is hard, the person is not good, but along the way, as you try to understand the person, as you interact, you realize that actually the person is not the problem. All these things you see in real life applies also to academics. Yes, it applies to academics. But your efforts as a person, your efforts as a person matters. Your efforts as a person matters. Okay? However much I may cut numbers here, I may do many numbers. But if you don't get pen, if you don't get your book, if you don't get your calculator and do these numbers alone, trust me, you will not appreciate actually the concepts. This applies to all topics you are doing and to all subjects. Don't be scared by the passing rate, colleagues, and you be scared that you will fail. Who told you that you will fail? You can. you can actually pass. You can be among the 20%. Colleagues, are you hearing me? Are you hearing me?
Yes, we are hearing you.
Yes, yes. I have to bring in that thing because I see most people being demotivated by the paper, especially when it comes to papers with calculation, math calculation. This is not accounting, this is actually mathematics. And you find that from maybe from your high school or from maybe the course you did, you didn't do accounting and finance, you didn't do even the other mathematics of A level or sub. You find that actually you're scared. You are saying that I will not manage this subject. You can manage. You can manage. That's just appreciate, because this course doesn't actually have only accountants. Even engineers can do. Even doctors can do. Even lawyers can do. Even farmers can do. You get? So as long as you qualify, you qualify, as long as you're given a course. So just know you will pass the subject. Put it in your mind that you can pass the subject, and you can pass these, you can actually do these numbers very well. Very well. You can. What I don't want is you to cram. Don't cram things. Don't cram. If you cram, you will find that you need a lot of time. People who cram need a lot of time, by the way, let me tell you. But people who understand they don't need a lot of time. They just understand from the word go, they understand, then they proceed to the next. But if you try to cram, you will keep on repeating on things, keep on repeating on things, and you don't have that time. Okay? Don't read the marking guides. Don't base on the marking guides. Don't base on the marking guides. Try to understand the concepts and appreciate. Whether you are doing FA, the same applies, or other subjects. Okay? So that was commercial break. We are going to calculations. So we can start. By now, I think you can actually answer Roman 1. So this is question 1. They are telling us distinguish between hypothesis and hypothesis testing. I believe you can score that.
Hypothesis is the belief, opinion.
Yes. But you add that word stated.
Testing is a process.
Then this hypothesis, this is what you state. Hypothesis is what you state as your assumption or as your belief or as your opinion about something. Then hypothesis testing is actually the process you are going to follow to confirm whether what you stated is true or false. Are we together? Roman 2. They are telling us that a farm produces electric bulbs. A random sample of 1,000 bulbs has a mean life for each bulb equal to 1,200 hours and a standard deviation of 210 hours. Required, calculate the 95% level of confidence. Are you seeing that? Calculate the 95% level of confidence for the mean population life of the bulbs. So if they just say calculate the 95% level of confidence, the only way to answer this is just to know that I am actually trying to get the range. I'm trying to get the range. I am given the percentage. This is a percentage of accuracy. That's why you have confidence. Level of confidence. Just to understand the level of confidence. That is like the percentage of accuracy. And I said, as we answer our questions, we focus on what? We focus on level of significance. Yes. So note what you're given from this question. We are given a sample. This is a sample size, 1,000 bulbs. We are given sample mean because they told us a random sample has a mean life for this. So this is not population mean. This is sample mean, and also this is sample standard deviation. So we can note what we are given. You get your books. We note what we are given. So question 1. Tell me what is sample size?
1,000.
And size is n, 1,000. Then what is our sample mean?
Mean is 1,200.
Sample mean. And we said the sign for sample mean is what?
X bar.
X bar. Which is equal to
1,200.
Pardon?
1,200.
Then what is the next information given?
1,200.
Standard deviation to 10
Sample.
hours.
Sample standard deviation
It's noted down.
is what?
S
10.
to 10.
10. Perfect. Then we are given a level of confidence.
Confidence
Level of confidence
which
as
is
what?
95%.
Pardon?
95%.
So what is level of significance?
5%.
Significance is 5%. We say that level of significance, that is percentage error, and is always the lower. Okay. So this is the information we are given, and they told us we actually calculate the range for population mean life. So population mean, which we said it is denoted as what?
Mu.
I know here some people cannot talk because of pronunciation. it will be equal to, but just understand the sign, pronunciation. You will pronounce it when you are a tutor. In an exam, you don't need to pronounce it. Okay. So we have the formula that we follow. We have the formula that we follow here as we get our range. As we get our range, it will be equal to x bar. It will be equal to x bar. Then you say minus O plus. Say minus O plus. Because you are trying to get range, minus O plus. Now, the question is, are we using t-test or are we using t-test or we are
Using Z.
using here we are
Using the Z.
using z-test because sample is what?
1,000 above
Sample, because n is above 30. So here you will say z, that is the value from the table, z alpha. You will put me just okay. Just use it. Here we are saying z, then here we put our alpha. Who's you seeing alpha? And let's put here alpha. Then we multiply by standard error. So colleagues, that is the formula. Is that a formula hard? And as you go to exams, they give you formulas, yes, but I encourage you to go know your formulas. You reach there and you try to look for formulas, and you find that the formula you are trying to find out is not given. There is only that formula that is not given. So don't think that all formulas can be given. Some will be given, some will not be given. So do we have mean? Remember, I said we use for standard error, for SE, standard error. This is standard error. I said when we are dealing with one mean, which formula do we use? Do you recall? When you're dealing with one mean, this is the formula we use. We get standard deviation.
Divide by standard
deviation, then we divide by root n. And standard deviation for sample is denoted as n. Is denoted as S, isn't it?
Which was given. So
you can substitute and tell me what is standard error.
You're not clear. Could it be my network? Oh, I don't know whether it is everybody getting that problem.
Is someone asking?
Yes.
Yes, go
Saying that
ahead. I'm not getting your question. Please feel free to ask. That person was saying what?
The network was not clear, like I keep on breaking, but I don't know now whether it has stabilized.
Is it the same to you or colleagues? Or it's his network? Please confirm whether it is my network or his network.
I think it's his network.
Okay, okay. So what is the standard deviation? The standard deviation here. Now you need to get calculator and we follow together. Standard deviation here is 210. Then we divide by root n. Root n is 1000. What do you get as your standard error?
6.64.
6.641.
6.641. Let's maintain 3 decimal points. From our formula, do you have Z alpha? That is the value from the table. Do you have it?
And
We don't have this value, but we can get.
mm,
We don't have this value, but we can actually get. And that value will be this is like our value from the table. But how do you get that value from the table? You will need to ask yourself, are you going to do, is this a two-tailed? Ask yourself, because this is already our level of significance, but we need to ask ourselves, ask yourself, is this a two-tailed test? Two-tailed test or one-tailed test? Are we dealing with a two-tailed test or one-tailed test? And colleagues, if you're dealing with confidence interval, if you're dealing with range, of course you don't have the side. One-tailed test is used if you have the side. If you have the side, you see our diagram. Where is our diagram? I didn't include it here. I think I should bring that diagram here. It's going to help us in more. It's going to help us somewhere. Let me just have this information in this document. And I can press it. Let me press it here. Let me press it here. Oh. Which screen are you seeing?
critical region.
What about now?
Where there is a diagram.
Are you seeing
Yes.
type 1, Aaron? Okay. I'm saying this diagram will be applied somewhere. So I was talking about one-tailed. You see, if it is one-tailed, you have a side. You are either focusing on positive values, that is from this moving forward to your right. You are either focusing on right side only, or you are focusing on left side only. That is if you're dealing with one-tailed test. You have the side. You don't need to separate the what? You don't need to divide the diagram. You don't need to create this side or this side. No, you must be focusing on one side. But with two-tailed test, you don't know the side to focus on. So if you don't know the side to focus on, then I will have to put here a critical value. I also put here a critical value. Separate, create my acceptance region and rejection region. But if you're dealing with one-tailed test, it means that you don't need to create this region. You will have to create here. You have to create here one critical value. You create one critical value and work accordingly. But if you want to understand it clearly, when it comes to our scenario here, this question, we don't have the sign. We don't know whether, like this one, whether we should put a critical value here.
I beg a little. Excuse me, I beg a little.
Yes, please.
Well, my concern comes from, like, what are the features in that question that can make you know that this question is a two-tailed or a one-tailed test question?
Thank you for your question. By the time we finish all these questions, you will actually appreciate how to distinguish between one-tailed test and two-tailed test. Just follow up to the end. Are we together?
Okay.
Start with, every time you're dealing with a question that is telling you to find out range, just to know you don't have the sign. You don't know whether you're dealing with negative value or you're dealing with positive values. So in such a scenario, it means as you get your critical value, it means you cannot actually say, let me only put my critical value here only. No, because you don't know whether the value is, you don't know whether the side is negative or positive. So in such scenario, you create one figure on right and another figure on left, so that you can have your acceptance region and the rejection region. Okay, so every time the question is asking you range or confidence interval, always know that you are dealing with a two-tailed test. As long as the question is about getting range, that is a confidence interval, then it's what? It's two-tailed test. That is number one. Daniel, that is number one so far. Are we together? That is number one. Every time, remember now you try to understand when are we supposed to apply two-tailed, when are we supposed to apply one-tailed. Now the condition number one is, as long as the question is about getting range or confidence interval, automatically that is what? Two-tailed test. And if it is two-tailed test, it means what? It means that as you go to read the value from the table, you immediately first get this value and divide by 2. The reason why you're dividing it by 2 is to create this. Are you seeing that? Is to create this. Is to create line on the left and another line on the right. To create 2 critical values. That is the reason we want to divide this 5% level of significance by 2. Because we are dealing with a two-tailed test. So if you divide, what do you get?
0.0.
2 points. This is like 0.005 divided by 2. What do you get?
0.02.
0.025. That should be your first step. As long as you realize that I'm dealing with a two-tailed test. Because I want to create 2 critical values, one on the left, one on the right. So I have to divide. But if it is one-tailed test, you don't divide by 2. You will be if it is one-tailed test, it means that you will be having only one value, which is this one. Okay. Are we okay here? Once you get this, colleagues, we know that this step, this diagram, from here up to infinity, it's 0.1, it's 0.5. Then from here also going to left to infinity, it is 0.5. That is if you're dealing with Z test. From here, from this line, going to infinity on right, it is 0.5. Then here, from here to left, it is 0.5. So it means that if I want to know from here to here, or from here to here, I must get 0.5. Then I subtract what? 0.025. What do you get?
Come again. Why are we using 0.5 instead of 0.05?
0.05 was just 5%. Now we are on the next step, whereby I said you have known now you have 2 sides. Each side is 0.0 what? 0.025. But we want to read the value from the table, and we know that with Z test, from here, from this line to infinity, from here, you see, just this diagram, this line should not touch. This line should not touch. Your line, this curve, should not touch the horizontal line. So I was trying to mean that from here to infinity, because this line does not touch the horizontal line, from here to infinity, it is 0.5. Then also from here to infinity is 0.5. So what does that one mean? You want to read the value from here to here. As you read the value from the table, our focus is from here to here. Okay? And how do you get the value from here to here? Because we know that from here to here is 0.5, from here to infinity is 0.5, and we know that the value we got after dividing by 2 is 0.025. We get the value to infinity, that is 0.5 minus 0.025. Are you now okay?
Yes, thank you.
And what do you get? Colleagues, this is where people fail from. Simple things. And a person will start recruiting others. The topic is hard. Topic is hard. Telling their friends, topic is hard. It is not hard. You are getting things wrongly. Don't recruit others, I repeat.
75.
So 0 point what?
0.475.
0.475. So this is the value we should read from the table. This is the value we should read from the table. This is like the probability. This is like the probability, because we know that probability, if you add 0.5 plus 0.5, the probability is always equal to what? To 1. So this is like the probability.
1.
Look at this as probability. So we need to know which value of Z actually helped you to get that probability. So we need to know from the table, from Z table, which value is going to help you to get this probability? Which value is going to help you to get this probability? And now we use Z table. We use Z table. Do you have Z table? If you don't have, we can follow together here. This is the first table is Z. You see here, PZ. They are telling you the values you have within the table are probability. That's why you have PZ. Then Z is here, Z value. And when we are reading Z values, we start from here, then after we use the column here. So the question is, which probability do we have? We have 0 point what?
475.
So you come here from, you observe, these are the probabilities you have, these ones. So you look for where you have 475. From all these values you have, from here up to here, which value is 475? So your focus should be to start from where you have 7, isn't it? You need 475. So you should not start from here. No, immediately go to where you have 47, and now start analyzing. Because you have many 47, then you can now start adjusting, moving left, moving left side. This is you actually look for where 47 starts from. It is 475, isn't it? So it means that I can look for where is this is 473, this is 473, this is 47. Are you seeing this? This is 4750. Then here it is 4744. Are you seeing that? Remember, we need 475. So your focus should be here. If you come here, you see you are exceeding what? You are exceeding 475. So your focus should be here. Your focus should be here. So between this and this, which one are you going to take? Which one gives you the most accurate one? Is it this? Because if you see this one,
1.6.
it is 4744. If we add the, because here there is column for add. So here, if I pick this and I add, let's say 5, and I add, let's say 5, I will get, remember that 5 you are adding on 4, that's 4 on your right. This is 4744. If I, let's say I add 5, I will have 4749. Then if I round, becomes 475. Then here, if I pick any value here, the last value, let's say 5, and I add it to 0. Are you seeing what I'm doing, colleagues? I am picking this 4744. Then I pick the highest value this side. The highest value is 5, isn't it? And that 5 you are picking, you are going to add it to the last 4 on your right. You don't add it on the first 4, but you add it to the last 4 on right. And if you add it to the last 4 on right, it becomes 4749. Are we together? And if it is 4749, if you round off 3 decimal points, you will have 47 what? 5. But here, if I pick another 5 here and I add it to 0, it will be 5. And if I round off, it will be 4755. And if I round off 3 decimal points, it will be 476. But what I can say at the end of it all, someone who has picked this and someone who has picked this, all of you can be marked right. Because we know the problem can come from where? The problem can come from rounding off, like rounding off and all that. They always create that provision. So the value from the table is, which value is giving us this? Let's just pick this. Or if you want, you pick this. Which value is giving us this?
1.9.
We take 47. So which value is giving us this? It is 1 point. You will start from 1.9. Then the meeting point. Look at the column that is giving you the meeting point. This is the column. So the column that is giving us the meeting point is 6. So the value from the table is 1.96. That is the value of Z. And another person who can decide to pick this, you will not be wrong. You can actually say for you, it is 1.9 what? 95.
95.
But my emphasis is to know how can you actually read the value from the table. Okay. Okay. So are you all fine about how we get the value from the table? So once you have Z, it means that we have everything on our formula. We can substitute. Where there is X bar, put your mean is what? Your sample mean is 1,200. Then what is your value from the table?
1.96.
This is 1.96. Then times what is your standard error?
6.641.
6.641. So if you proceed, what will be the value here? If you get 1.96 times 6.641, what do you get?
It is 13.016.
016. So you have this as your new. This is your range. But the fact that with range, we always need lower limit. And what will be your lower limit here? You get 1,200. Then you subtract. That's why you have here minus or plus to get lower limit and upper limit. So here we are subtracting 13.016. And what do you get?
You get 1,186.9.
Pardon?
1,186.9.
186.9. That's what you have.
Yes.
Perfect. So we get also upper limit. Upper limit is equal to where you have here you now add. We get this, then plus 13.016. And what do you get? In the chat is saying, someone in the chat is saying it is 1,186.983. 983. If you want to make it a whole number, it is approximately equal to what? 1187, isn't it? Remember, these are bulbs. What about here? This is 1,213.016, which is approximately equal to 1,213 bulbs. So finally, your population mean falls within this range, 187 bulbs. Then you put less less or equal to less or equal to new. This is new. This is new. Then less or equal to less or equal to 1, 2, 1, 3 variables. Are you seeing that? My conclusion?
Mm.
Population. If there is a question, you can ask. Population mean is equal to this. So this is basically your range. It means that your population mean is either equal to this or above. It should not be below. It should not be below this. And it should not exceed what? It should not exceed this. That is confidence. That is confidence interval. Okay, we have answered the Roman, rather this. Oh, yes. It is in the variables. Okay. Any question? That can be taking like 5 marks or 8 marks, depending. And you see, we are taking a lot of time because I'm over explaining. But you see, you can actually answer this in less than 4 minutes. Part A, they are telling us that a manager of a private security organization believes that the mean wage of a private guard is shillings 135,000 per month, with a standard deviation of shillings 30,000. However, a random sample of 120 private guards revealed that the mean wage is shillings 132,000 per month, and the required part, we have to test the manager's belief at 5% level of significance. So this question is totally different from the first one. It's totally different from computing the what? The confidence interval. Totally different. Here you will need, as you test, we always need the computed value. That is the value of test statistic. Then we also need the value from the table. Those are the two things that we need. The computed value and the value from the table. But we can get. So we note down what we are given. They are telling us a manager of a private security organization believes that. So it means that you need to state your null hypothesis. You need to state your alternative hypothesis, which is different from confidence interval. With confidence interval, we are not interested in what? In the stating hypothesis. But here you must state, because at the end of it all, you want to test. So what will be your null hypothesis here? This manager believes that the mean wage of a private guard is what? Is this one per month. So that is your null hypothesis. The belief stated in the question. The belief stated in the question. So we can state our null hypothesis. This is a question. Question 3. Our hypothesis, our null hypothesis. Remember, this is always the belief stated, the one you want to test. Here, we are going to say what? Just copy and paste. Believe that the mean now start from here, state what is given. Believe that the mean wage of a private guard is shilling 35, so 135,000. The mean wage of private security guard is equal to shillings 35,000 per month. So that is our null hypothesis. Or another person can just use sign. What is the remember, if you observe here, they have used the mean of private security guard. It means that you're looking at the overall organization. Yeah? You're just looking at the overall. This is not the sample. This is not the sample mean wage. No. This is the overall for the whole population. This is for the whole population. So it means that if you want to use the sign, you don't use X bar. You use what? Hey, no one is talking. I know.
You use mu.
I know because we are talking about this sign. So that is our null hypothesis. What about alternative hypothesis? Alternative hypothesis. So we are going to say here, what is the opposite of this? We are going to say that the mean wage of private security guard is not equal to shillings 135. So it means that here your new is what? Or you can say, or another person can just use signs and say new. What is it? Is not equal to, is not, I can use this.
Abe. Hello?
Yes, please. Yes.
Suppose you say that the sample mean is equal to 132,000.
No. We put what the examiner believes, what this manager believes. Remember, when you observe the question, from here up to here, you are not seeing anywhere sample. a manager of a private security organization believes that this is his opinion, believes that the mean wage, he or she has not said the sample mean, he has said the mean wage of a private security guard is this one. So don't mix.
Meant for the mean, not the population mean, but for the sample mean.
No, if you say the sample mean, you are diverting from the belief. You are diverting from the belief. Remember, this sample mean 132 is what was revealed. From your sample, you revealed this.
Okay.
But at first, we need to know at first, what was the stated belief? Are we together? Are you okay now? We cannot use the
Yes.
sample mean. We have to use the population mean here because it's the one stated. It's the one stated. But you will test later. Okay. Okay. So colleagues, I want to ask you now, you have stated your null hypothesis and alternative hypothesis. The question is, are you dealing with one-tailed test or two-tailed test? For you to confirm that you're dealing with one-tailed test or two-tailed test, always look at the alternative. If the alternative does not show the side, if the alternative does not show the side, then what you're dealing with is two-tailed test. Daniel, are you okay?
I'm getting you.
This is where people confuse things. What do you mean by sides? Like now here, the mean wage of a private security guard is not equal to shilling this. The question is, do you have a side? Because we know that amount can be higher or what? Lower. So the side we are talking about, is it a higher figure or a lower figure? You see, you don't have the side where you should focus on. Should we focus on greater side or we focus on lower side? At this point, you don't know. That's why I am saying you don't have the side. In a situation where you don't have the side, whether to focus on the higher figure or the lower figure, then in such scenario, you are dealing with a two-tailed test. But if we knew the side, if at all, let's say, this manager said the mean wage of population security is less or equal to, if the manager said he believes that the mean wage of private security is less or equal to 135,000, then it means that here we could put less or equal to this, then alternative would be what? Would be to say the mean wage of private security guard is greater than 135,000. And in such scenario, you would be having the side. you would be having the side on the alternative. And every time you have the side on the alternative, then you'll be dealing with one-third test. I believe I have communicated. Jimmy, is it clear? Agnes, Bridget, Hillary, are you people okay? Patricia, Derek, you are quiet. You are very quiet today. What's up? Are you in the church but putting on the session? Okay, colleagues, let's proceed. But if you need more clarification, please ask. I am very slow. I'm very slow because once you understand the starting point, it can help you to answer even the following questions. Every time you realize that here you have the side, you are dealing with one-third test. Every time you realize that here you are not having the side, you are just there. You don't know whether to focus on the higher figure or the lower figure. Then that is two-tailed test. And if it is two-tailed test, it means that you must divide your level of significance by 2. And if it is one-tailed test, we don't divide that level of significance by 2. Okay. Now we can start answering. As you answer, after stating your null hypothesis and alternative hypothesis, next is to look for you can start with the computed value. How do you get the computed value? So before you go to computed value, what are we dealing with? Now we have understood that we are dealing with two-tailed test here. Another question is, are we dealing with Z test or T test? What is our sample?
120.
120. This is above 30. Automatically, here we are dealing with two-tailed test. And also we are dealing with Z test because n is greater than 30. Here because we don't have a side on alternative, the alternative hypothesis. Okay. So you can decide is a max. You can decide by reading the value from the table. That is, if I'm in an exam, if I'm the one doing a paper, I can actually start with the value from the table because order does not matter. We need the value. Colleagues, here we need value from the table. Let's be fast, value from the table. And value from the table, we are saying we are dealing with Z distribution table. So what is level of significance? Level of significance. This is the first marker you should score. Level of significance is equal to what? The lower percentage. Here the percentage was 5%. So this is the lower percentage. The lower percentage is always the level of significance. The higher percentage is confidence level. Here confidence level would be 95%. Confidence level, that is level of accuracy. Then level of significance, that is a percentage error. Okay, here is 5%. But the fact that we are dealing with two-tailed test, we divide this by 2 because we are dealing with two-tailed test. So divide it by 2 since it is two-tailed test. And what do you get? 0.05 divided by 2. We get 0.0025. That is step number 1. Whether you are dealing with Z test or T test, as long as it is two-tailed test, we always divide by 2. The difference between Z test and T test is the next step. That with Z test, we have to get 0.5 minus 0.025, which is equal to what? 0.475. But with t-test, we don't do this step. Once you confirm that this is the value, now get V, your V, which is n minus 1. But once you confirm that it is Z test, this should be your next step. And this is your probability. We need to read the value that gives us this probability on Z distribution table. So what is the Z value from the table? From the table that gives us 0.475. That value is what? I think we already have this value, but for a recap, you just come kindly mute. You just come to your Z table. You look for where you have 0.75, which is here. And which value of Z gives you this? We start from here. This is Z column. So here we are. This is 1.9. Then the column that is giving you this is column what? 6. So we read that, which is 1.96. So that is our value from the table. We need also computed value of Z. That is the value of test statistic. The test we are using here is Z test. So how do you get the computed value? We use the formula. The computed value, when you are dealing with one sample mean. When we are dealing with 1 mean, it will be equal to X bar, that is sample sample mean, that is X bar. Then you subtract your new, that is population mean. Then here down we divide by a standard error. Standard error. Standard error of population, rather of sample mean. This is like a formula that you must know. That if I'm dealing with only one mean, this is the what? So, do you have X bar is your sample mean? In the question, do we have sample mean? In the question, do we have population mean? In the question, do we have standard error? And the standard error, remember you are dealing with one mean, the formula remains the same. Where we say the standard error is standard deviation, then divide by root 2, divided by root 2, you divide by root n. That is if you are dealing with the sample that is above 30. If it is below 30, it is n minus 1. So sample mean is what? Talk.
132.
132. Then the population mean?
135.
135. Then what is our standard error? You just get, do we have standard deviation directly in the question? If you are not given a standard deviation and you're given variance, you take square root of variance. So what is standard deviation? Is it given directly?
It is given in
Yes.
30.
Standard deviation, where are we? Standard deviation, where are we? Standard deviation. It is this one. Just take what you're given. So get, I didn't see the figure. It is what?
30.
So it is 30. 30. Then divide by root n. You divide by root n. What do you get? Root n. N is what? Here n is, our n is what?
120.
Our n is equal to 120. So get 30,000 divided by root 120. What do you get? Root 120. Okay, just tell me what is standard error. Tell me what is standard error. Get 30,000 divided by root 120. Just tell me one figure in 3 decimal points. The overall figure. 3 decimal points. Someone is saying 86. That's what you're getting. Someone is saying 86.61. All of you, that's what you're getting in 3 decimal points. On your calculator, just write 30,000 divided by right root 120. Then click equal signs.
2738.6.
Divided by 120. I am having you people,
27
you people. This is
738
38.6.
12.
13. If you round off 3 decimal points. Then this is our standard error. We have everything now. We can substitute in the formula and get the answer. Substitute in the formula and get the computed value of Z is equal to mean, which is 132. Then our population mean is 135. Then our standard error is 22738.613. Finally, what do you get?
Negative 1.095.
1095.
5.
Like,
Point
like,
negative 1 point.
pardon?
Negative 1.095.
095. Like this, eh?
Yes.
Okay. So this is negative. So what will happen is, once you get this, bring your cut table. Once you get this value, we have 2 methods to conclude. But I want here, we focus on this. I want to focus on this. Here we put what was the value from the table. Remember, it is our critical value, the one that separates acceptance region from rejection region. What is the value from the table?
1.96.
0.96. And since we don't have the side, we said that we create the same value, but we make it a negative 1.96. Because we don't have the side, that's why we are creating a positive and negative. Then once you do that, place your computed value. Ask yourself, remember this is acceptance region. Ask yourself, does this figure fall within the acceptance region? If the answer is yes, you are going to accept null hypothesis. If the computed value fall within the acceptance region, then accept your null hypothesis. But if it falls outside the acceptance region, it means that you are going to reject null hypothesis. Does it fall within the acceptance region or not?
It falls within the acceptance region.
Because this is negative 1.96 and the negative 0.9 is around here. So it falls within the acceptance region. Falls within the acceptance region. And for that, and therefore, since the computed value, since the computed value of Z, that is negative 1.095, lies within the acceptance region. Accept the null hypothesis. And what is that null hypothesis? Therefore, you conclude by that statement corresponding to null hypothesis. Therefore, what was our null hypothesis? Therefore, you put this. Therefore, you can confirm that the population mean of private security is equal to this. If it falls outside, we reject null and accept alternative. Then we conclude with alternative statement, which is this one. So that's all, colleagues. Even in t-test, you do the same. Now, if you want to use method one, then this method one of saying if the value from the table. Remember, the values you read from the table are positive values. So it means that for you to create a comparison, you need to get the absolute value. You will need to get absolute value of this by just making this one a positive. Then you compare, because you cannot compare negative value yet the value from the table you read positive values. That's why you have to. And remember, if you're using this method, we said that you accept null hypothesis if the value from the table is greater than what? The computed value. And if we make you observe that if we make this one absolute value, or if we make this one a positive value, you can still confirm that the value from the table 1.96 is greater than 1.095. And if in such scenario, you find that it is greater, if the value from the table that is 9.9, that is 1.96, is greater than the computed value, 1.09, then accept. Are you seeing the logic, colleagues? So if you want to use this method, make sure that you are comparing a positive value with a positive value. We don't expect you to compare negatives, no. But if you're using this method, then just do like this. So you choose the method that is easier to your side. Any question?